whereby sometimes you actually be given functions graphs that you are working with. We are not, do not expect a question which is straightforward on the straight line graphs. That is why we in most cases we find a challenge on this part, because we do not have actually a question specifically which is going to be like in paper 2. We are just focusing with the straight line graphs. We are going to be given here and there properties of the straight line graphs from paper 1. In paper 2, you are not going to have a specific question on a straight line graph, but you are going to draw these straight lines in linear programming, which is our inequalities. There is no way you can present a certain inequality if you do not know how to draw that line. So you are forced to refer back to your straight line graphs. Transformation, talking of, there's a transformation that we refer, which is the reflection. It considers the equation of the mirror line. That mirror line, it's a straight line. So you also need that part. So mostly straight lines, they are actually asked as applications. We are going to see these as applications on other topics. What is it that you are considering on a straight line? From our Cartesian plan, this is our Cartesian plan. With the Cartesian plan, we can draw any function. Any function. So a straight line, it's a linear function. That's a straight line. So it has properties, or we have got properties that we need to consider when working with a straight line. So before we refer to the drawing of the straight line, the first thing is that the format that we have, which format are you going to consider? So a linear function is the one that is given of the format of y is equal to mx plus c. When we are referring to this format here, we are going to explain, I'm going to talk about much later on. M, the gradient, the y-intercept, those are the properties, but here is like the format. If you check properly, you're going to see y is written in terms of x. M and c are constants. These are numbers that are to be found. Y is equal to maybe 2x plus 3. So these are numbers. We're not going to talk about this for now. It's y in terms of x. So x is raised to the power of what? Of 1. That is to be linear. Linear. Just like linear equations, 2x plus 1 is equal to 3. So for x, it's a linear from the exponent, the power that is affecting x. The highest power is 1. So any equation that you are going to have, as long it's not a fraction like this, as long it's not a fraction, any equation that you're going to have of y written in terms of x being of the power 1, that equation is going to form a straight line. Any equation, whether we transposed these, it's now y minus 3 is equal to 2x, whether we transposed these to the other side, y minus 2x minus 3 is equal to 0. It's still a straight line. We just change numbers this to that. Nothing has changed. If the format, like the exponent on x is still a 1, it's still a straight line. You are given this y minus 2x is equal to 3, is still a straight line. The highest power on x is 1. So the question is, how are we going to draw this line? We have got properties there later on. To determine this gradient, even to determine the equation. We'll talk about that later on. So the question is on how to draw a straight line. You are given this line of y is equal to mx plus c of this format. How can we present this graphically? So to draw a straight line, there are so many ways, many methods that we can actually apply in order for us to end up with a straight line. So like I said, there are so many formats. Y is equal, might be given in the form y is equal to mx plus c, ax plus by is equal to c. As long the highest power that you're given is 1, the highest power on x is supposed to be a 1. Y is equal to x squared is something else. The highest power is now a 2. It's no longer a straight line. Once you join the points by just having the points on your graph, they are not going to produce a straight line. They are going to produce something else. As long the highest power is 1, we are back to the straight line. So to draw a straight line, there are methods, like I said. We have got the first part, which is the use of the table of values. The table of values, which is the TOV method. A table of values shows or can give us a relationship between x and y. So a function, which is a graph that we are talking about, a function, it has the input values. The x values are called, or they are referred, the input values. These are the input values. Whether you are you're not presenting mathematically, you are in any other subject that you might talk about, whenever you have input, you are given input. What else do you expect to have from our science? We've got the input values, which will give us the output. Talk of even any reaction that you are given. You have got input, the inputs and the outputs. So the X is referred as the input. This is what you insert into the equation. You insert the X values, meaning to say the X values, they control the Y values. X is the input. The input controls the output. You input a certain value, output a certain value. So X values are the inputs. So meaning, as you are to draw this graph, you focus with the X values along the X-axis. These are the values that you focus on or that you concentrate on. You insert these values to obtain the Y values, which are the output values now. So for each X value, it has an output, which is the Y value. So that is the use of the table of values. The table of values, it relates between the input and output values. Relates between the input and output values. Meaning to say the X and the Y values. So you choose, this is a straight line that you have to draw. Let's say you're given 2 points. Okay. Let's say you're given this 2 points. It's a point here. There is another point here. With these 2 points that we are given, hatikwanisi draw a line for my points are 2. We can. A straight line, you can go join it on my points are 2, just to join these 2 points. A straight line is. So in actual sense, 2 points are enough to draw a straight line. 2 points are actually enough to draw a straight line because there 2 my points are per graph. Those points are enough. If I have a point here and another point here, these 2 points, they are enough for us to have a straight line by joining the 2 points. But for the base of because as we are to draw these functions, somehow you are bound to mistakes. You might mistakenly substitute a certain value, or maybe in calculations, quite a mistake. With the 2 points, it is going to be difficult for you to note that you have made a mistake because you can just join those 2 points. Line ratovepo. There is no reference that you can ever have. Apana reference is this correct or not? Haukwanisi kuona mistake. So we encourage you guys to at least use 3 points in calculations, in drawing of a straight line. Why using 3 points? If I have a point here, another point here, then I mistakenly calculate the 3rd point over here. That is my 3rd point. I have indicated on the graph, 1st point, 2nd point, then the 3rd point is here. At the end, I'm supposed to have a straight line. This is not a straight line. It's no longer a straight line. That's what shape and out to get. So that alone tells us there's something which is wrong. It's either this point, it's either this point. So having 3 points is not part that allowance. The Vita go back to the given points that you are having to cross-check, because you are not given my points. It is you who is supposed to calculate these points or mark my points. So if you are having 3 points now, that is the advantage. So at least use use at least 3 points in on your table of values. So you're going to insert the X, which is the input. to obtain the output. Chinotanga input, kuti output. That is what I'm trying to say. So meaning to say it's a table that shows the input, which is X, and the output, which is Y. So like I said, 3 points are enough to have the function. So on your table of values, you are going to indicate at least 3 points. So the X values are the input, these values here. It's just like any other part where the input is your decision. I want to put this, but the output now is controlled with what you're given on the input. So let's say we are given an equation, which is the presentation of our straight line. Y is equal to 2x plus 3. You are going to insert the X values of your choice because these are the inputs. Input is your choice. But as you are inserting these X values, they are also affected with your Cartesian plane. Remember, you have a Cartesian plane. A certain interval where you are given X is greater than or equal to -4, less than or equal to 5. That interval is for a certain reason, not only a certain purpose that it serves. You do not just draw, you do not just take any X value. It's true that you choose that X value of your choice. But as you choose that X value, you are limited to a certain interval. That is the interval that you work with for X. So haungonotori any X value ngoti ndangonakirwa na2 na3. No. Aripo here pa-interval yakapiwa. If it is inside or in within that interval, then you can choose that value. And also, in choosing that value, you also, because this is the output, you also consider your output value and the X value, what will be the output, and also that output, does it corresponds to what I'm given, because you're also controlled in terms of the Y values from a certain value to a certain. So the values that you're going to pick here, make sure they are also within the interval in terms of the Y. So pick a point, you substitute that point, you will not, the Y value is not within. Because sometimes they're not certain. It's not like you're going to be sure about this point, each other interval, no. But as you are calculating, it's rare actually that you substitute these points within the interval, then you obtain values which are outside of the interval. But when it happens, you choose another point because it's a choice, you pick. So this is what I'm trying to say. Let's say we have got -1, -2, -3, and so on. 1, 2, 3, 4. These are the input values of X. So that is where we are going to choose any 3 of your choice. So you just choose separately the X values. Let's say I pick -2. Okay, let's say I have the -2. I have the 0. I have the 2. You're just separating your points. You can pick -1, 1, 3. It's not like you're supposed to take my points following each other, 1, 2, 3. Just try to separate your points. Is 1, 2, 3, but in terms of a proper presentation, just try to separate your points. You can pick -1, 0, 1. It's up to you. The X values, like I said, it's your choice. So let's say I choose a -3, 0, and 1. these x values are supposed to be on the Cartesian plane. You do not just pick any x value which is not within interval. It must be within the interval. So this is your choice, meaning to say your choice and my choice might be different. Umwe ari kusarudza -2, 0 and 2. Umwe ari kusarudza -1, 0 and 3. At the end, these points that we are going to have, they are going to lie on the same straight line. This is a straight line. They are all the points they are going to lie on the straight line. So meaning to say, maybe we have picked -2, -1, and 0. These are the points our picker. Another one from the points I picker, it was this point, and this point, and this point. They are different points. But at the end, these points, where they are found on the same line. So by joining, we are going to have the same line. Tashandisa ma different points, as line ratikunowana is supposed to be the same. Meaning to say, you are not limited in terms of the x. It's a choice. All right. So do not be limited to my values and calculator. They are different. Kune abudis on someone. No, that one is not a problem. Draw your line. Then you compare your line at the end. Line rata draw rakafanana ye. Do straight line. So that is the idea there. You're done. So you're just gonna substitute your x values to obtain the y values. When x is -3, you are substituting into the equation that you are given of 2x, that one that will be given. That is where you're substituting. So in place of x, you are going to substitute the x value. This is our input. And x are -3, y indian. So you just substitute in place of x. So the equation, the presentation of the equation, in a answer the 3x minus y is equal to 0 or whatever that you're given. No. Presentation in bus. Chakakosha, is it a straight line? This x, the power is 1, so it's a straight line. So when x is -3, we're going to substitute as long it's a straight line. We're going to substitute pana x -3. Then you solve for y. So it's not like when you are given this format, you stress now to filter y the subject. That one it's a choice if you want to make y the subject. Whether the equation was given as 3x minus 2y is equal to 5. Substitute where there is x, then you solve for y. So this one, it is just an advantage that already y is the subject. If you have to check y is already the subject, so as you are inserting the x values, you're automatically determining the y value. So that's 2 times -3, which is -6 plus 3, which is something like -3. So that's the output, which is the y value. When x is -3, the output is -3. You do the same thing. When this x is equal to 0, in place of x, you substitute. That's 2 times 0 plus 3, which is going to be 0 plus 3, which is 3. The same thing, if this x is a 1, you substitute 2 times 1, which is 2, plus 3, which is a 5. So these are the input values that you're substituting in place of x to obtain the output values. So it's something that is corresponding, a point. This one, it's a point, pointing. X into -3, y into -3. This one, it's a point. X is 0, y is 3. This one is a point. X is 1, Y is 5. With these points, you can draw a straight line by marking these points on your Cartesian plane. By marking these points on your Cartesian plane. So as you mark my points, X versus Y, X versus Y. So this part that I'm explaining, each other the same that you're going to use on any other graph. Remember input and output values, whether we are talking of a quadratic graph, we are talking of a cubic function, an inverse function. So ngatobata the concept chirungonozosiyana, or what is going to differ there is the shape, the shape, what you have at the end. A quadratic graph is different from a straight line graph. The shape, the cubic is different. That is the difference that you're having at the end. But how we are going to have this in terms of the input using the table value is the same. But on a straight line, we've got other methods, methods that those ones we can even refer on revisions, just for the basics of understanding other methods, methods that you can use. But the table of values, this one, is the best. It can be used on any graph, any equation, whether equation as a, so very mindful on these questions, because we're not going to do all these equations. It's because of format. One was going to put a trick, just like y is equal to x minus 3 over 2. Guys, hapana kana chambobvunzwa. Zvangofanana nekutapiwa isusu equation yakanzi 2y is equal to x minus 3. What is it that we are having? It's a straight line. So hazvichinjisi straight line kuti tadivide na 2 kana. No. This does not change. Still, we're talking of a straight line. They will try to confuse you here and there, but know the concept. Chaita kuti this is a straight line. Chi, highest power, and x is 1. And it's not supposed to be a fraction. When I'm saying it's not supposed to be a fraction, remember 1 over x, no matter how it looks like, kuti x akatakura power ya 1. That is not it. If you get back to your exponents, 1 over x x to the power of minus 1. So that is why I'm saying my fractions, this is the Ashatoshand. My fractions are Ashatoshand, because the moment you take x kutoku, anengakatakura negative. But this one, you can't say this is a fraction, nokuti 30 over 2. No. When I'm saying a fraction, I'm saying x in the denominator. This x here is in the numerator. Achira katakura power yake ya 1. So it's still a straight line. All right. So I want us to take to look closely into this table of values, because I'm going to use this table of values to draw the line on the next page. So just look closely on the values. So on these values that you are given, these are the values now that you're going to present on the graph. So you'll be given a scale 2 centimeters to represent this and that according to the person that you're given. There may be a scale of 2 centimeters to represent 1 unit on both axes. Remember, 2 centimeters ndo box rese riri complete. So maybe this is what you're given. And for those vaiti ma graphs out, they are not enough, like animal box are enough. Just remind me to send this one, a soft copy of this one, so that you can make printouts. So this one, it's actually good. Even it's different from the other one that we used to have. Even when you are drawing, really are affecting, like the other one ranga rine kakunetsa karaita, even the boxes were not that clear. So for those vari munomu vane challenge graph books, because munonetsa kuti graph books akasiyana neekumusha. So for those who are here, just remind me to go send this one. So you can make printouts. You can make my printouts so that you can do as much practice as you can. So this one really enough to even cover up mama areas or mama topics, such as when a transformation and this and that. So just remind me. Then pamozoita ma printouts if you are printing somewhere, but they know those guys, but try it even per scale of 120, even per 120%. Kune vanozonoprinta, I just tell them kuti inge iri pa 120%, isange iri pa 100. If it is at 100%, it'll be like rinenge rakashrink a little bit. So they use 120% when they are printing. But those guys vanoziva vanoprinta kuti zvingaita sei kuti rinyatsokwana pa page. So you can use that one. All right, no problem. So we said from the table that you are given, if you saw properly, tangatine ma x and y, tangatine ma x and y values there. The x, the first one, it was -3, -3, 0, 3, and 1, 5. These are the values at tangati now. So you mark these points. Now it's a point, like I was indicating before. This one is a point, x versus y. X ndi -3, y ndi -3. So meaning to say on your graph, you're going to indicate where x is -3. Remember, x-axis, these are the x values. And the y values are along this side. So when x is -3, y is also -3. Pazvinosangana is -3 kunoko na -3 kunoko. Zvonosangana at a certain point. Where they meet, you mark a point. So unongono mark a point, pazvinonosangana. That's the intersection of the two values, x nani, x na y. That is your auto indicator point, x, then y. You move on to the other point, x it's 0 when y is 3. X is 0 there when y is 3. X is 0. These are the x values. X panenga is 0. That is at this point. But y has a value. Y equals d -3. So meaning to say this point is on the y-axis, direct pana -3, direct. All the points
I don't think it's
positive.
Positive 3.
It's 3.
All right, thank you for that. That's a positive 3 there. So all the points, all the points akatakura as 0, whether it's like this, whether it's like this, 0, 2, 3, 0, 3, like this. Okay. All the points that are going to be having a 0 like this one, y is 0 on this part, meaning to say atina anything to consider on y. you mark direct pana x, which is 2. So not in the direct pana x, which is 2. Ndopa mark a point. If it is given like this 0, 3, atina chatinacho pana x, there is nothing on x. But y is there. Y and a certain value, there's a value of y which is 3. So you mark and a value pana 3. So that is how you can get rid of that confusion. Ekuti ndoenda papi pana 3 wekunani pane value the papi. The value is for y. So you mark pana y. Okay. Another point, it was 1, 5. When x is 1, this is x, y is 5. So x is 1, y is 5. So no sangana at a certain point where they meet, no marker that point. So you're going to mark point there, 1, 5. So at the end, you are going to see that only that these points are a little bit far away, like, but if you to consider this point to this point to that first point that we had, all these points pakagara panofanwa kuti a straight line at the end. We are supposed to obtain a straight line. So you join these points using a ruler. You're going to join these points using a ruler. That is the idea. So meaning to say, in this case, I'm just gonna join using this one, but they're supposed to use a ruler, and you join my points T now. Okay, from this point, just gonna try for my points attacker marker. So something like this. All right, so just something like that. So you mark my points first. So what is supposed to be visible are the points. These points must be visible. My points. So that is the idea. How you draw a straight line. So after that, you write down the equation of the straight line. Remember our equation. It was given as y is equal to 2x plus 3. Every function you will not draw, you must indicate its equation. It's a quadratic, it's a cubic, whatever function you will draw, equation at the end. That's how you can draw a straight line. I don't know if you're together.
Yes, we are together.
Yes, we are together.
So meaning to say that anga anima points ake akasiyana. My points where they are going to be on the same straight line. Maybe you picked or used -2. That -2, as we can see, parnosangana per line, it's -2, -1. X is -2, Y it's minus. Meaning to say, if we are to substitute these points, the same thing. Let's just try 1 and see. I want you to see it. Why not say the same thing? Let's say our equation there, it was y is equal to 2x plus 3. This is our equation. And maybe these are not the points that you picked. Or pick out something else. You picked -2. Toda kuona kuti -2 uyo wanga uchapika uyu achanogara here same line iradrowa someone using other points. This is to show us that truly you can draw a straight line using any points of your choice. All right, let's just take this -2. When x is -2, you substitute in place of -2. We want to see kuti they substitute at this point on your table of values. They want going to -2. What was going to be the y value? Okay, 2 times -2, that is -4 plus 3, which is what? -1. As we can see, y are going to output at -1 as The output is at what? -1, which is exactly that we are seeing here. -2, the output value kunoku ndiani? Ndi -1 kuna y. Meaning to say, the point that you are going to mark your point here, you're going to mark your point here, you're going to, at the end, my points are, they are on the same straight line. So no matter the way that you're going to have, on the way that you pick your points or pick up my points are whether they're in the positive side, at the end, ese anonoenda paline rimwe chete. So this is the idea that you're going to use. So like I said, kune methods akawanda atinokwanisa kushandisa kudraw malines. There are so many methods that we can use. So the first part is the table of values, which focuses on the output and input, where the output is controlled by the input. So first, you have to insert the input values, which are the x values. Any linear function, that we are given, with this, we can draw any graph of a linear function, any linear function. So I want us to try as many questions as we can. Draw these graphs to naguti tiri same page. Are we on the same page here? So even if you are given this one, in most cases we have challenges like someone asking, what about the line of y is equal to x? On this one, we are already like y na x y is equal to x. X is equal to y. A is equal to B, B is equal to A. So if A is 2, it means B is also 2.
Sorry.
Yes.
Kushandisa vana zvamatipe zvoti tidrowe magraphs. Y minus 2x is equal to 3. Y is equal to 3x plus 1.
Or yes, you can even draw these ones for practice sake, no problem.
Okay.
You can draw these ones for practice sake, then we can send them after that or not. So just try to have your table of values draw, then you scan, send it as a PDF in group.
Okay.
So when y is equal to x, is the same. Y and x, they're just the same. So if you're to have a table, even if you're to have a table of values, let's say urikuda kuita table values. This is x, this is y. Remember the table values, it's your choice. X values are of your choice. These ones are choice. When x is -2, when x is 0, when x is 2. You just picked out of your choice from the x. This is your input. So you can substitute when x is -2 in place of x. And x are -2, y in the end, the -2. If x is 0, y is 0. When x is 2, y is also 2, 3, and they're just the same. Do not confuse with this one of y is equal to -x. Minus. Pana minus. So this one, it tells us that for each and every value of x that you insert, it must be multiplied by a minus. Every x value I will insert upon. y is equal to minus, it's already on the formula. But x is minus 2. Minus atogara ari formula kudhara. But there is a minus 2 that we have inserted into the formula. So the minus and the minus will be a positive. There is nothing like minus 0. 0 is neutral. Plus or minus 0 is just a 0. You insert 2 in place of x. So y is equal to minus, which is already on the formula. But x in the 2. So minus times 2, it becomes minus 2. So be careful when it is of this nature. All right, so let's just conclude with this one of y is equal to x. You're going to try to draw this one of y is equal to minus x, but let's just have this one together. There are some properties that I want to explain at the end. So with this one, when x is minus 2, we said y is minus 2. So let's mark the first point. X is minus 2, y is minus 2. So minus 2, minus 2. Okay. The next value, we have got 0 versus 0 versus 0. And x is 0, y is 0. And the papi pana x r is 0, y also r is 0 at the origin. So this one is referred to as the origin. Sangana ma points are 0 na 0. Okay. Then the last one, it is 2 versus 2. X kana ari 2, y indi 2. 2 versus 2. X is 2, y is 2. They meet at this point. That is where you mark the point. X being 2, y being 2. Okay. My points are, they are enough. R3 could annotate a straight line. Like I said before, what you need is to join my points are to form a straight line at the end. So by this, we're going to have something of this nature. All right. So here, as you are using your ruler, remember, you are using a ruler. So on a ruler, you can even see my points are a straight line. So here, I'm just using the knowledge of the straight line, but on a ruler, so you see, right, my points are Buddha on a straight line or not. So this is our graph, y is equal to x. By joining my points at now, tabudisa this line. So this line, without the line, because it has some properties that you can consider and in practice that you will not even need to use the table of values by understanding these properties. Provided that the scale is the same, that is the first thing. Provided you are given the same scale. Provided that the scale is the same throughout. This graph is going to divide this line that we've drawn. It is going to divide our graph into 2 equal parts vertical in this vertical manner. It will not divide. If you see this box, it will not divide into 2 equal parts. So if you understand this concept, you see that, all right, so this one, you're not divided upon, I don't need the table values. But be careful, because I'm saying only if the scale is the same. What am I trying to say? 2 centimeters to represent 2 centimeters to represent. Zvikangonosiyana chete. Line haripfuuri rakadai. So be careful on that part. So it's rather you stick to the table values also, all right? My points are because Zvikangonosiyana chete scale. I want you to see, let me conclude with this one. We're done. So that you do not have confusion at the end, because this part it can happen, and you think that it's actually rofa kuno divider graph rank into two equal parts. It is because tangatine the same scale. All right. Not to this one. Not to honor this one. I want to remove this to conclude this one. I want us to conclude this part. Given a scale of 2 centimeters to represent 1 unit on the x-axis and 2 centimeters to represent 2 units on the y-axis. We're just going to quickly talk about this so that we can conclude on this graph. -2, -4, -6. Let's say I've got 2, 4, 6. These are the y values and x values. So we're saying the scale is different. 2 centimeters to 1 unit on the x. 2 centimeters to 2 units on the y. Okay. Remember, line run y is equal to x. This is our line. Let us say for our table values. The table values is not going to change. I affect ne scale yatakapiwa, no. The table values noramba yakadaro. Zvichireva kuti patanga achiti isusu when x is -1, y haasi kunochinja, ari kunoramba ari -1. If we are saying x is equal to -2, y haasi kuchinja, ari kungoramba ari -2. If x is 0, ari kungoramba ari 0. If x is 2, ari kungoramba ari 2. 1 versus hapana chachinja. What is just affected at the end is on the presentation. Ichokwadi kuti tatoenda pana -2 na -2. Asi maitikiro azviri kuipa graph apa ndopega pangochinja kuti kuna -2 kuna x nekuna -2 kuna y. Toona kuti pane difference, gap there is too much. Ndozvingonosiyanisa, asi ndi -2 wekuna x zvichokwadi. It's the same -2 of x, the same -2 of y. 0 versus 0, 2 versus 2 is the same 2 on x, the same 2 on y. Zvichokwadi. But because of the presentation of the scale, which is presented differently, line redu iri harinotipi ma-properties aranga rifange atipa before. Remember, ma-properties that taitiropa unodivider graph redu into 2 equal parts. Izvozvo hazvichashandi this time. Wait. Tikanonyatsotarisa line redu iri, we are going to see it's no longer dividing our graph into 2 equal parts. The previous line of y is equal to x, rari chipfuura nepanapa, ranga chinodivide box iri. Rari chidividwa nepakati pana box iri. Zvichinda zvakadai box iri. Zvacho ndo mabox anga chidividwa. This is how the line was dividing our box. Ndo zvarabuda rakaita. Divide into 2 equal parts. But it's no longer like that on this Cartesian plane. Chasiyanisa, it is the Cartesian plane. It is the same line of y is equal to x. So this is what I'm trying to say. Ukada kuno analyze out. Frane pakati. Chokwadi kana scale yakafanana. 1, 2, 3, 1, 2, 3, same scale. 2 centimeters, 1 unit. 2 centimeters, 1 unit. Zvechokwadi, rinopfuura chinodivider graph redu into 2 equal parts. If you can understand that way, it's fine. So my advice is that chingoziva, just know your table of values, y and x are the same. You insert your points on the graph. You never go wrong whether uri kuziva ma-properties or wakanganwa this one, you never go wrong. There are properties that we teach you guys later, but wakutoziva topic. Those properties tisamatanga nawo kushanda nawo as a topic, no. So I hope from our basics we can do as many questions on this part of the straight line graph. So like I said, let's try. Yes, Alam. Okay, is it okay?
Sakati kushandisa scale yatinoda.
All right, yes, on the scale, all right, just for the sake of let's use the scale of 2 centimeters to represent 1 unit on both axes, using a scale of 2 centimeters to represent 1 unit on both axes, meaning to say y na x pamwe chete.
Okay, sir.
All right, so let's try as many questions as we can. And on these ones, let's also add this one, the last one. I'm going to add this one, something that is mixed. Let us just add something that is mixed. X minus 3y is equal to 1. And also y is equal to x plus 1 over 2. Yes. So, ngatingono add something. These are all straight lines. The highest power ichingori panani pana 1. So we send our work, then we are going to talk of the linear programming later on. It has an extended part from these straight lines. I won't understand linear programming without this knowledge. So let's just work on that, and also just trust about calculating, determining this equation. Yet equation, you'll be given a straight line. You want to determine the equation of a straight line. So I think we can finalize our straight lines in our next class tomorrow.
Okay, say pane screenshot ndakusendera group, so pane video ramakaita reseko geo ku YouTube introduction yange iri paZoom. Pane bhuku ramaishandisa so rine manotes. Kana minaro ndikukumbira.
Okay, that PDF. I see. Let me check. I think I have that PDF. I think I have
Thank you.
that PDF. So I'm going to check it. So then we'll see from there. Let's see.
Don't forget to send the graph.
Hello?
I said don't forget to send the graph.
Okay. Yes. I'm gonna send it. Let me just try to send it now.